So hi everybody, I hope you've enjoyed EgoVis so far. We've had some excellent talks from some of our Aria partners here today as well. So I'm excited to give you an overview of Project Aria to those of you that are new to the community and show some updates to our program for those that are used to the usage of Aria and have Aria. And I also have with me here today, so I'm James Ford, I'm a research product manager with Meta Reality Labs Research. And Hyo-Jin Kim is here with me today. She's a research scientist in our organization, and Cheng Peng is a research engineer in our organization. And we'll be talking about three different topics today. One is Project Aria. We'll also show a live demo, and then we'll talk about a new data set that we have. So let's dig in. So just as some context, over 2 million Ray-Ban Meta glasses have been sold in the world since its debut at the end of 2023. And with its RGB camera, audio interactivity, and seamless connection to Meta AI, we're now watching the world adopt what Meta and this community of egocentric researchers have envisioned for years. At Meta, we believe the evolution of egocentric wearable devices and the ever-growing capabilities of vision language models will transform the way we think of personal computing. It will become more invisible, interfacing for us across language boundaries and anticipating the information we need in the moment. And we're also at an inflection point in the robotics space. So how many of the people in this room have a focus or interest in research on robotics? Can I get a show of hands? Cool. We've got about half the people in this room now focused on robotics. So large language models evolved into vision language models, which are now evolving into vision language action models that can perceive the world and act directly from trained models. Robotics hardware platforms are at a state of affordability such that the computer vision community can develop experimental platforms. And a proliferation of large corporations and startups have begun developing humanoid robots with impressive demonstrations. Computing is becoming embodied in the form of humanoid robots. Wearable devices and humanoid robots both perceive the world from their own perspective, and that's what we mean by the egocentric perspective. In order to train these vision language models and vision language action models to operate in domains where they can offer value to us, they need to be trained with data that represents what we experience, in-domain data. As you can see in this example from the HOT 3D dataset, which is available for download now, egocentric data captures the wearer's point of view and includes important information about the wearer's gaze, their position in 3D space, and how they are interacting with their environment using their hands as an important signal. And to put it simply, effective contextual AI systems for wearables and machine learned models for robot operation need egocentric data, and they need a whole lot of it. And as a community, we're asking critical questions about how much data is needed for breakthroughs in performance, how specific the data needs to be for certain tasks, and how easily models can perform well on different sensor configurations, and even in different robot embodiments. And this leads to the mission of Project Aria. We started Project Aria in 2020 to accelerate machine perception and contextual AI research for wearables and robotics. And since then, both we and Meta and the brilliant minds in the egocentric research community have used Aria to generate new kinds of egocentric data sets, to train and benchmark state-of-the-art models, and created prototype experiences and demonstrations that illustrate what's possible with wearables and in robotics. You've already seen examples of this today, and many more exciting research applications are in the works, I can tell you from working with many of our researchers. So the first generation of Project Aria, which we now call Aria Gen 1, was launched in 2020, and our external program has grown tremendously since that launch. If you apply to be a partner to do research with Aria today, which I'll give you links for, we currently give out Aria Gen 1 glasses. Aria Gen 1 glasses are packed with sensors that capture the egocentric perspective. They contain a high-resolution 8-megapixel RGB camera, 2 high field of view computer vision cameras for SLAM and hand tracking, 2 low-power eye tracking cameras, dual IMUs for trajectory and SLAM, and 7 spatialized microphones. The device contains a 2.5 watt-hour battery that can record up to several hours with certain sensor configurations, and a 128 gigabyte flash drive. It's truly a miniaturized computer in a pair of glasses. Over 240 research partners in 27 countries use now 1,000 Aria Gen 1 glasses. And these are really the top computer vision labs, contextual AI labs, human-computer interaction researchers, and now a growing number of roboticists worldwide. We now count 340 citations of Project Aria and Aria Dataset papers, spanning a breadth of publications that focus on the evaluation of vision language models with egocentric data, to new innovations in robot training methods, to foundation model development. And just earlier this year, we were really excited to announce Aria Gen 2, our latest hardware with many improvements. We are working hard to make Aria Gen 2 available to the community in H1 of 2026. I'll go into some exciting details about Aria Gen 2 now so that you can begin to formulate a sense of how you might use Aria Gen 2 in your own research. So Aria Gen 2 provides a step change in usability and capability for the egocentric research community in several dimensions. One, it's more wearable with 8 different sizes to accommodate various human factors. 2, there are significant upgrades to the sensor suite. And it has on-device real-time machine perception capabilities and audio to enable interactive experiences. Here's an overview of the sensors and connectivity on Aria Gen 2. I'll just point out a few key features. You can charge and connect Gen 2 with a standard USB-C port. That's a major convenience upgrade. The 8-megapixel RGB camera on Aria Gen 1 has been upgraded to a 12-megapixel camera with better dynamic range. There are now 4 CV cameras instead of 2 for a greater field of view and significant stereo overlap in the CV cameras. And there's a contact microphone that makes it possible to have voice experiences in noisy environments. Here's a view showing the high dynamic range in our RGB and CV cameras that makes it easy to work with Aria Gen 2 in dynamic lighting conditions. And the detail that's perhaps most interesting here is look at the filament in the CV camera on the left in the high definition camera feed that we have. And also look at the detail outside. You can make out the detail of the tree with respect to the background of the lighting. And this enables applications like SLAM in various lighting environments. The addition of more CV cameras in Gen 2 with strategic positioning downward and out to the side produces significantly more stereo overlap. And I'll shortly show how that enables Gen 2 to effectively operate as a depth camera when paired with a state-of-the-art depth model. It also captures hand movement from more natural positions for hand tracking applications with its downward-facing cameras. And then let me see if I can get some audio here. Might not be able to pick up the audio directly from my computer. I'll just voice over here. I don't think I can pick up the audio. This is a simulation of Aria being used in a wind tunnel where there's significant noise coming through over the glasses. And if you just use the regular microphone, all you hear is noise. But the contact microphone picks up the speaker's voice through contact through the nose bridge and transmits the voice completely separate of the surrounding noise. Perhaps the biggest change for Aria Gen 2 is that Meta developed its own specialized coprocessor for real-time ultra-low power computation of machine perception signals, previously only computed offline on machine perception services as an offline process once the recording is completed. For dataset creation, this can save enormous effort in long-duration recordings where the MP signals get included directly in the recording itself. And if you don't need the raw camera streams, you can even omit them altogether from the saved data and just retain the MP signal. But it also opens up other possibilities of creating applications that can use MP signals directly in real time via streaming. Gen 2 will have the ability to perform automatic speech recognition on the device directly as well, and you can imagine starting to build conversational experiences directly with the device. When we provide Project Aria to qualified partners, we don't just provide the glasses. We actually provide Aria Research Kit, which is a comprehensive set of tools for creating data sets and prototyping experiences. At a high level, Aria Research Kit is composed of the Aria glasses, a mobile companion app that runs on your mobile phone, a client SDK on your PC, and machine perception capabilities, which either run on device if we're talking about Gen 2, or they run in a service that we offer if you're working with Gen 1 device. And we also have tools for analyzing, visualizing, processing, and packaging the data. And we've observed that the community have two primary use cases for Aria Research Kit. One is dataset creation. You've seen already two pretty groundbreaking data sets being presented here today in this workshop. I'll talk about those more. And then the other is prototyping, creating prototyping experiences with our SDK. So I'll talk about the components of Aria Research Kit through the lens of these two major workflows. So I'll start with dataset creation. We've seen a proliferation of egocentric datasets with Aria. For example, Ego XO40 we talked about in quite some detail today. And we will talk about actually three new datasets over the course of this presentation. We'll talk about HD Epic, which I know you already heard about earlier today, and there are challenges around. But just in the context of using the device, we'll talk about it a little more. And then Nanyang Technological University presented their EgoLife dataset, which is a very interesting dataset. And Meta's own dataset in collaboration with Ohio State University that we'll talk about today. Hyo-Jin will talk about reading in the wild. Aria Research Kit makes dataset creation straightforward with watertight calibration across sensors and easy ways to align multiple Aria doing recording at once. There are profiles that can easily be configured to dial in sensor configurations most optimal for your end research goals. And we make our core machine perception algorithms, which are location, hand, and eye, that were originally developed for AR applications as contextual signals, available to you. And lastly, we make it easy to load, analyze, prepare, and package your data set for model training, benchmarking, and open sourcing. So let's start with RGB camera calibration. With Aria Gen 1 now, and of course with Aria Gen 2, we offer RGB online camera calibration, which enables near pixel perfect projection of masks that are computed in 3D back into the RGB camera frame. And it's crucial for sensitive applications like 3D scene reconstruction. And if you watch this yellow line sort of swiping back and forth across the scene reconstruction, what you'll notice is that the details are much, much clearer on one side of the line than the other. Take a close look at some of these decals. Take a look at the tree, and look left to right. You can see just factory calibrated versus online calibrated. On the right, it's much clearer in some of these fine details. And this kind of thing might seem subtle when you're observing it here just casually, but when you're talking about an immersive VR application, for example, this detail is critical. And then here's a closer view of what I mean by time alignment. And when you're doing something like, for example, multi-view applications, it's critical to get two devices that are viewing the same thing, very accurately time aligned. And you can try to do that manually, but in doing so manually, as a best effort, you can see on the left, when we really zoom in on a particular crop of the image, and we zoom in time, meaning make it slow down, we can see it's quite off. But if we use the automatic tools that are available for both Gen 1 and Gen 2, you can perfectly time align these to like the couple of millisecond level. And that's really going to make anything around multi-view research much more accurate. And now with Aria Gen 1, we've implemented color correction in the recordings directly on the OS. So any new recordings will be color corrected from the previous slightly bluish tint that was observable in some of the recordings. And then we also offer tools to back post-process anything that you've already recorded. And then we also offer tools to de-vignette the recordings. And this shows an example in the middle. This is essentially the fixed recording referenced against a DSLR camera. And it's very, very close. So you've seen this amazing sensor suite that we provide with Aria Gen 1 and Aria Gen 2, and you can create massive data sets very quickly if you put all the sensors at full blast in terms of frequency and in terms of resolution, but you can dial it back to whatever your application is on a per sensor basis, and that concept is called profiles. So even with the battery that we've been able to pack into Aria, lasting a couple of hours for certain applications, you want to optimize for battery life, and you also want to optimize for disk space that's both on the device and when you're packaging up your large data set for open sourcing. And so using profiles is the way to do this. It's achieved with high control and resolution and frame rate over each of the sensors. And you can select profiles via the SDK or the mobile companion app, and we even offer something called a custom profile where you can dial in the exact profile you want. And with Aria Gen 2, you'll be able to control the frequency of calculation of machine perception signals. You can even choose not to save the underlying raw sensor data, and you can save just the final computed signal in certain cases, and that'll save a lot of raw data consumption on the disk. So now I'll segue to talk about our machine perception signals in some more detail. And these are capabilities available on Aria Gen 1 via computation and machine perception services. That's an offline workflow where you, after recording, you compute things. And then on Gen 2, you can compute them on device in real time, and you can even stream them in Gen 2. And I'll start with talking about the human-oriented signals. And we have algorithms available for computing eye gaze vector and hand pose, and that provides information to infer the wearer's state, what they're interacting with, what they're interested in. You can imagine many implications for using these human-oriented signals about what we're doing when we're interacting with our environment. And a lot of you, especially those working on things like dexterous robotic hands, I wish Xiaolong were still in the audience, have asked for fully articulated hand poses. And fully articulated hand pose means we offer 21 landmarks and a wrist transform in 3D space, so you can get the exact position of each of the hand joints in 3D space. So this is a new thing that we've released for Aria Gen 1. If you're using MPS, try it out. Let us know how it goes. And then we compute the trajectory of the glasses in 3D space. We use visual inertial odometry, and it's extremely accurate over long distances. This visualization shows the trajectory as the glasses visualized on a person that's walking around. And so we've even gone a step further and used this trajectory as an input to compute the whole body human pose, which we've done in some of our research. And you can look up some of the work that Lingni Ma has done around this. And she'll actually be presenting more for EgoLM a little bit later in the conference. You can look that up. And then with machine perception services, you can go the next level and compute loop closure with visual inertial bundle adjustment for further accuracy of the trajectory. And then you can compute semi-dense point clouds that represent the surrounding space at a high level of geometric detail that's computed on top of the SLAM map as an output. And it can be used for things like a spatial reconstruction algorithm or just to generally provide context of the scene in which you're computing trajectory. Aria recordings are basically stored in something called a VRS file on your machine. That's a special container that can house multimodal data and will even house machine perception data. And Aria Studio makes it easy on your local machine to manage those VRS files. You can pull over the VRS files from your glasses after plugging them into your machine, transfer them to the PC. You can submit them to machine perception services for signal processing. And then once on your PC, you can use Project Aria tools to load, visualize, further edit, and prepare your data set for open sourcing. And finally, if you want to use Aria data for model fine-tuning or training or benchmarking, Aria Training and Evaluation Kit makes it straightforward to prepare your data for PyTorch with simple pipelines that can be easily configured with YAML files. So this is a quick look at some recent highlights from the community. I think you've seen some of these today. This is just really exciting work from our perspective, having seen our partners use Aria for a couple of years now. University of Bristol developed HD Epic. That's an egocentric data set focused on very high annotation detail for VLM and LLM benchmarking. Nanyang Technological University went in a different direction and created very long time frame egocentric recordings over the course of an entire week for long duration Q&A. And in the robotics space, Georgia Tech released their method EgoMimic, which leverages what they call scaled human data collection with Aria for robot imitation learning. This is a groundbreaking method that enables data collected in a very simple way to be used for training robots. And then very recently, NYU and Berkeley teamed up to release EgoZero, and that's a key point-based imitation learning method that learns from human data and transfers zero shot to a robotic gripper arm. And now I want to pass things off to Hyo-Jin, who's going to talk about reading recognition in the wild. Take it away.
Thank you, James. Hi, my name is Hyo-Jin Kim. I'm a research scientist at Meta Reality Labs, and I'm pleased to introduce our Reading in the Wild dataset to the world for the first time. This is a year of effort in the making with our amazing intern Cherry Yang in collaboration with the Ohio State University, with Professor Mi Jang's team, and many of our team members from Project Aria team. Reading is a fundamental way for humans to communicate, learn, entertain, and navigate the world. It spans a wide range of mediums, from handwritten notes and printed books to digital screens and environmental signage. The future of AI relies heavily on understanding the user's physical context. Therefore, the ability to recognize when the user is reading and keeping the record of it is essential for developing AI that is truly personalized and contextually aware. However, simply having the text in the field of view does not mean that user is reading, which makes it difficult to solve using visual information alone. Also, any solution must be efficient for real-time, always-on wearable devices. Current OCR technology requires high-resolution images, resulting in significant power consumption. If we can detect when the user is reading, we can only trigger OCR at the time when the user is actively engaged with the reading material. To address this, we introduced the Reading in the Wild dataset. Reading in the Wild dataset is a first-of-its-kind dataset designed to understand the reading behavior of people in realistic settings with high-frequency eye-tracking information. It features high-frequency eye-tracking data of 60 Hz captured with Project Aria glasses, encompassing 100 hours of reading and non-reading activities with 111 participants. The dataset covers more than 150 reading materials with 19 high-level scenarios, and is captured in various locations, both indoor and outdoors. It also includes non-reading activities containing both daily activities and hard negatives where the text is present but not being read. Each sequence contains RGB slam camera videos, audio, IMU, and barometer, and 60 Hz high-frequency eye tracking with 3D gaze ray and estimated depths. And in addition to eye tracking, we also provide hand tracking, head poses, and semi-dense point clouds thanks to Aria machine perception service. And we also provide rich annotation that includes start and end time of reading, types of reading material, types of reading modes, and the content. As mentioned earlier, our dataset includes over 150 reading materials across 3 different mediums: digital, print, and objects, with varying types of content, such as long paragraphs, such as books or articles, short text, such as posters or labels, and with non-textual content, such as diagrams or maps. Our dataset also includes multiple reading modes, including skimming, scanning, reading out loud, multitasking, such as reading while walking or reading while writing or typing, and it also includes reading captions from videos. Along with the dataset, we have developed a lightweight, flexible model for reading recognition that achieves high precision and recall. This model is a multimodal transformer encoder with only 130K parameters. It can effectively utilize low-power sensors, including eye gaze, foveated RGB patches with only 5 degrees field of view, and head pose data, either individually or in any combination, thanks to modality dropout during training. A comprehensive analysis of our model is provided in our technical report. You can see our reading recognition model in action on the right. So the colored dots represent 2D projected eye gaze, and the red squares represent the foveated RGB patches that is fed to the model. So you can download the dataset today at the project page up here, and you can read more about our model and the dataset and in our technical report on archive. Thank you very much. And I'll hand over to James.
Thanks, Hyo-Jin. Okay, now that we've covered dataset creation, I want to talk about real-time experience prototyping. This is the second major workflow. So the main thing to talk about here is the Aria Client SDK. And this enables the Aria glasses to stream data and machine perception signals starting with Aria Gen 2 to a client PC where any number of experiences can be built from consuming and processing the data streams. So you can imagine anything you can essentially run in real time on your PC, you could run on top of the data streams. And likewise with Gen 2, these experiences can be made interactive by enabling the user to interact with the SDK using automatic speech recognition from the device. So imagine you're talking to the device. It has automatic speech recognition running on the device. It's sending that text over through to your PC. Maybe you have an LLM that's running on your PC, and then it can provide audio feedback to you via the glasses via a speaker. So you can start to get creative with the kinds of experiences you can build. This is an example of using Gen 2's capabilities and extending with the client SDK. And what you're looking at here is Aria is streaming the sensor data. You can see the 4 computer vision cameras in black and white, 1, 2, 3, 4 in this column on the left. And then at the bottom you have a representation of depth. And we're actually using NVIDIA's Breakthrough Foundation stereo model, which I've heard all over this conference today for some really interesting examples to compute near metric depth from Gen 2's overlapping stereo cameras. I mentioned there's 80 degrees overlap. And this is actually fused with Connect Fusion to create a very realistic depth representation mesh. And for everyone that's been asking for a depth camera, I've been hearing that from many partners. When will Aria have a depth camera? This is the answer that we have for depth. And give it a try. I encourage everybody to try this out. So one more example, totally different kind of example, using the SDK is something that you probably saw when we announced Aria Gen 2 towards the beginning of the year. And this is a demonstration that we created with the company Envision, showing how Aria can be used as a tool for audio navigation for the blind in a grocery store. And this is really about the audio interactivity and also the mapping capabilities, essentially using VIO and the SLAM capabilities that we have. So maybe next year at EgoVis we can have some community demos of people that have used Aria Gen 2. And I would love to see maybe not just data sets, but also what people can do in interactive experiences. And we at Meta, we predict that the fields of computer vision and human-computer interaction are going to start merging more and more because these tools enable people to not just create static data sets, which will always be important for benchmarking and measurement and training, but also have these interactive kind of experiences. So just really quickly now, we're going to jump into a demonstration that Cheng and I are going to do showing the SDK. Cheng's wearing Gen 2, as you can see here. It's 74 to 76 grams, depending on the size. It's a very wearable device, foldable device. And you're seeing now up on the screen many different sensor streams plus MP signals. That would be easier, thank you. Let's see if this works. Okay, this is easier. So what you can see on the right is the RGB camera. It's probably the most obvious thing to look at. And the green dot that's overlaid onto the RGB camera is the eye gaze projected back into the RGB camera frame. On the left, you can see a 3D view of where the glasses are in space, and you can see a trace of the glasses position that's representing our VIO running. It's basically tracking in extreme accuracy the head pose. As Cheng is just moving just a little bit, you can even see rotations. And the other thing that's going on here, you can see the 4 CV cameras at the bottom left. These are very distinct views because there are 2 cameras that are facing down, and then there are 2 cameras that are facing out. And maybe something very interesting to look at is as Cheng starts to spread his hands more towards his periphery, they're still capturing the view in these CV cameras, specifically on the bottom left, if you take a look, you can see how far out to his periphery we're capturing the signal. It's a major upgrade from Aria Gen 1, and you can start to think about, how much more data you can get and what an egocentric capture would mean, right? I was just having a conversation with Dima about, like, what does egocentric really mean? And it's about capturing everything around your field of view that you experience, not just a forward-facing camera. So I'm really excited to see what people can do by extending with these additional cameras. And then, another thing to point out, if anybody hasn't tried it yet via MPS, is we get this full 21 key point output. Maybe if you can show it projected in the RGB camera frame. You can see good articulation of the hands if you do movement, and that's really exciting. And then if you look in the bottom right, what's interesting is you can see this audio waveform that's playing. Well, that's, the microphone picking up my voice, which is the audio that's in the room, but we also have a contact mic. So now if Cheng starts speaking, as I'm speaking, you can see the bottom microphone. If you maybe say something, a couple of sentences while we kind of talk over each other here.
How are you?
Yeah, and just keep talking, keep going.
Okay.
Yeah, you can see now that my voice is going as his voice is going, but it's not picking up any of my signal as he's speaking. So this is pretty impressive. Capability of the contact microphone. And so you can imagine somebody walking around in a very dense environment. Yeah, that was our demonstration. Maybe I can take one more minute just to flash a slide. So I just want people to snap really quickly. You can get Aria data. You can apply for Aria Research Kit, and you can read more about Aria Gen 2 via these QR codes. And please come to our booth. It'll be right by the entrance, and we'll be there the whole week, and looking forward to talking to you in detail. Thanks for your time.